Yeah. Yes. Let us start session. Yes, guys. Good morning. Hi, guys. Good morning. Can you hear me? Hello.
Yes, Mr. Nageshwar, I'm able to hear you.
Yeah. Thank you. So we'll start session. Yeah. Your batch Java 11:45. Yeah. Yes. Introduction. So yesterday, what is Java? What are the contents of Java discussed? Okay. Just first 5 minutes. Let us review yesterday topic. This is. After that, we'll go to new topic. Okay. So what is Java? Yes, Java is an object-oriented programming language. Simple answer. It's an object-oriented programming language. Okay. Yes, anyone first interview. Yes, when you're facing interview, first question is what is Java? Simple answer. It's an object-oriented programming language. JDK. So JDK means Java Development Kit. JDK means Java Development Kit. Yes, first version of Java released in the year 1995. JDK 1.0 first version. Okay, so first version released with these features like independent platform, portability, OOPS language, scalability, and security. Next version 1.1 in the year 1996. In JDK 1.1, divided into three editions. Three editions. Three editions. Yes, standard edition, enterprise, mobile edition. Okay. Yes. Here later JDK 1.2, 1.3, 1.4. See version wise features we'll see next. After finishing your course, complete course, finally we'll discuss about version wise features. I think this is not right time to discuss. Okay, final topic we'll discuss. Okay. JDK 1.5, it's a Tiger version. Major changes were done. Okay. It was released near 2004. Okay, in yes, JDK 1.5, one more edition effects added. So finally Java divided into four editions. Standard edition, enterprise edition, yes, next. Yes, mobile edition and effects. Yes, next. Standard edition features. They're the features of standard edition, like core part of Java means compiler parts. Oops, concept implementation here. Next, string buffer, string builder, string tokenizer, data conversions using wrapper classes, exception handling, collections, IO streams, networking, multi-threading. Yes, up to this is our syllabus. Up to multi-threading. And Java 8, Java 9 features, our syllabus. Next, JDBC, AWT applets. So these SE features. Next, when come to W enterprise here, Solids, JSP, EJP, RMI, yes, Java Mail API, JMS or Kafka, Log4j, yes, services and components. Next, frameworks. Frameworks here, Struts framework, yes, Spring framework, yes, Hibernate framework, yes, Hadoop framework, Arc framework, Ignite framework, Angular framework. These all are the frameworks in Java. This is complete Java. This is complete Java here. See, enterprise, yes, services, components, frameworks. These are services. Next, they are the framework. This is complete Java. Okay. Now let us start from the beginning here. So first, independent platform. Okay, let us start with this independent platform. Okay, Java is an independent platform. Okay, Java is an independent platform. Okay. Yes, Angular framework. In the Angular framework also you can write Java. We can write Java language in Angular framework also. We can write it. Okay. Yes, in Angular framework, they say Node.js concept is available. Server side Node.js. Then you can write Java also. Okay. Yes. Independent of platform. So what is first? Let us start with independent of platform. So what is independent of platform? So what is independent of platform? Okay. So what is independent of platform? See, To understand independent platform, okay, you must have some basics. Okay, see platform means what? Ways. Yes, you must have the ways knowledge. That ways architecture. Yes, I'll explain now. Don't worry, I'll explain it here. Okay, independent platform. To understand these features here, yes, you must have that ways idea, ways knowledge. Next, what is interpreter? That about interpreter. What is interpreter? Okay, so what is interpreter? Next, what is compiler? Yes, you must have this knowledge. Otherwise, may not be understanding independent of. I can explain directly. I can explain Java features, but may not be understanding here. Okay, so ways knowledge, interpreter knowledge, compiler knowledge. Next, what is exe file? Okay, about exe file, you must have the understanding of exe file. Next, what is dot class file? Okay, what is exe file? What is dot class file? If you know about this, then easy to understand this first one, independent platform. Okay, right? Yes, next one, yes, portability. Portability. Yes, portability. Yes, for this are same. For independent platform portability, for these two features, yes, if you know these things, you can understand these two features. Okay, right? Yes, next one, OOPS language. Yes, to understand OOPS language here, to understand, yes, next one, OOPS language, to understand this here, you must have the knowledge of generation of languages. Okay, if you know the generation of language, then you can understand what is OOPS language. Okay, yes, so this is prior knowledge to understand Java features. So before going to Java features, let us have some discussion on this one here. What is ways? What is interpreter? What is compiler? What is exe file? What is dot class file? What are the generation of language? All of these things we'll discuss. After finishing, we'll go to Java features. Okay, 1 second. Yes, in document. Yes, in documents, everything prepared. Yes, this is your Java documents. Yes, around 500 page document here. This document for you only. Okay, this document for you only. Okay, I'll be sharing with you these documents. This document I'll be sharing with you. This is for you only here. Okay. Yes, in document everything is there. So no need of writing any running notes. Okay, running notes is not necessary. Running notes is not necessary here. So running notes is not necessary here. Just you can follow these documents. Just simply can follow these documents. Okay, 1 second. Yes. So try to follow these documents. 1 second. Network is okay. Fine. Yes. Just try to follow this document here. Running notes is not necessary. Just to follow this document here. Okay. Now let us start. See, Java. Before going to Java, features of Java. Before going to Java features here. Before going to this, first we'll discuss about these basics. If you know about these basics, then easy to understand Java features. Easy to understand. Okay. Easy to understand Java features. Okay. I can explain Java features directly, but may not be understanding here. Some little bit difficult to understand. So before that, just I'm explaining some basics like something like a yes, like a yes, what is software, what is system software, what is application software, next what is OS, what is OS, next what is front end, what is back end, what is language, what is package, next low level language, high level languages, next generation of languages. Okay, after that, what is interpreter and compiler, difference between interpreter and compiler. Okay, after that, Java depends on what, is it compiler or interpreter, these things here, these things we should discuss about exe file, about dot class file, all the things we should discuss. Once you finish here, then you can understand features of Java. Okay, now let us start from the basics. So before going to Java, there are some basics. Let us start with basics here. Let us start with basics. Okay, see here, my intention. everyone should understand my classes. Even non-IT background guy also should understand. That's the reason starting from very basics. Non-IT background guy also, all that guys, everyone has to understand. Okay, next one more thing here, some fundamentals. These fundamentals, some unknown facts. Even 10 years experienced guy also may not be known about this. The unknown facts, even 10 to 15 years guys also they don't know about these fundamentals. Okay, see, you should be in a position to answer every question, including fundamentals. Okay, every question you have to answer. For that reason, I'm starting from fundamentals. Okay, yes, let us start from the beginning. See, here they say computer aware, right? Computer aware. In computer aware, basically two categories. There is a hardware and software. Yes, hardware, those are physical components of a computer. We can touch all the hardware parts, but we are not hardware engineers. Yes, we are software engineers. So let us start software. Let us start with software. Let us start with software. Okay, our part is software. So what's a software? Okay, software. Software in software here, yes, everything is a program. Everything is a program. In software, everything is a program. Everything is a program. Okay, simply here, yes, it is a collection of programs. It's a collection. It's a collection of programs. It's a collection of programs. It's a collection of programs like C, C++, Java, yes, maybe Python, yes, Python, maybe Hadoop program, something like this. All are programs. Okay, it's a collection of programs. Software. In software, everything is program. In software, everything is program. Yes, it is a collection of programs. Yes, it is a collection of programs. It's a collection of programs. Okay, right? Yes, next step. In software, there are two categories. In software, there are two categories. First one, yes, system software. Second one, application software. System software, next is application software. System software, next is application software. Okay. In software, there are two categories. System software, next application software. 1 second. Yes. So in software, there are two categories. System software, next application software. See, Java comes under application software. Java comes under application software. So this is our topic. Before going to application software, let us see something about system software. So what is a system software? System software. System software is this one. This one interacts with hardware components. Interacts. This one interacts with the hardware components. Interacting with the hardware components. This one interacts with hardware components. Okay. This one interacts with the hardware components. System software interacts with hardware components. Yes, example. Yes, device drivers. Example, device drivers, and operating systems. Okay, and operating systems. Device drivers and operations comes on this category. Okay, system software. This one interacts with hardware components. Okay, example, device drivers and operating systems. Okay, yes, we'll discuss what is device driver, what is OS, we'll discuss. Wait. Next, application software. So what is application software? Application software, this is for the purpose of application development. So this is for the purpose of application development, applications apps. There are different apps like Facebook is an application. Yes, to develop the Facebook kind of application, some software is required. Okay, Facebook application. Suppose Flipkart, it's an application. Okay, suppose websites, company websites, applications. Okay, there are applications here. Okay, suppose WhatsApp. Yes, WhatsApp, it's an application. Okay, Yes, next Twitter is an application. Yes, Gmail it's an application. Yes, all the applications here. So how to develop such kind of applications? For this we need application softwares. Application softwares. Application softwares. Okay. Application softwares examples like C, yes, C++, Java, yes, maybe Hadoop, yes, Python. Pythons are all application softwares here. See, except ways. Except operating system, all are application softwares. Except ways, ways, all are application softwares, all are application softwares, all are application softwares. Okay, except ways. Ways means operating system like Windows, Linux, Unix. They are operating systems. Okay, 1 second. Yes, except ways, all are application softwares. All are application softwares like C, C++, Java, Hadoop, Python. Suppose some tools like in testing some Selenium tool, QTP tool. Next, reporting tools like ClickView, Tableau, BA tools. Yes, next, databases, Oracle database, MySQL database, even MS Office also comes under application softwares. All the application softwares, except ways, all are application softwares. Depends on requirements, we can use different kind of application softwares. Okay, fine. Now here, system software. In this, device drivers to run the devices. Okay, fine. Now let us go to ways. What is ways? Okay, operating systems. Okay, operating system. Now here, so what is ways? Let us see about ways here. What is ways? Here, this point is very, very important for us to understand Java features about ways. Yes, we'll say about that ways architecture. Okay. Now here, some question for you guys. Some question. Here's some question for you guys. Some question. Yes. Can we run? Question is, can we run? Can we run any program? Any program? Yes, without ways. Can we run any program without ways? That's a question. Can we run any program without ways? Yes, yes, guys. Can you answer? Anyone can answer this? Can we run any program without ways? Say yes or no. Simple answer, either yes or no. Can we run any program without ways? Say yes or no. Of course, I'm here to explain.
No, sir.
Your
No,
opinion. Yes, answer is no. Majority guys saying that no. Answer is no. No. Okay, ways required compulsory. Without ways, we cannot run any program. Compulsory ways required. Without ways, we cannot run programs. Compulsory ways required. Okay. Now question is here, what is operating system? Operating system. So what is operating system? Now question is what? Now question is what is ways? The question is what is ways? So what is ways? Let us see about ways. Yes, try to understand these ways clearly. Yes, try to understand this architecture. Now I'm explaining about ways architecture. To understand Java independent of platform, Java is an independent platform. Java is an independent platform. To understand that concept, you must have this ways knowledge. So for that reason, I'm explaining about ways architecture. Try to understand ways architecture. Okay, let us see about this. What is ways? So what is ways? See here, suppose your laptop, or suppose purchased laptop. So hardware, your laptop hardware. On top of it, next you have to install OS. After purchasing your hardware, next you have to install OS, operating system. Operating system you have to install. So once OS install, your system is ready. Suppose my system, yes, with OS at Windows OS, now system is ready. So OS system with OS. Without OS, system will not work. OS required compulsory. Okay. Yes, now system is ready with OS. So your system is ready with OS, right? Suppose learning C language, you have to install C software. Suppose learning C++, you have to install C++. Learning Java, Java, you have to install. Suppose using some database, Oracle database, the database you have to install. Database you have to install. Suppose working with Hadoop, Hadoop you have to install. Suppose Python programming, yes, then Python you have to install. Okay, yes, all their application softwares. All these are application. Yes, all these are application softwares. All their application software. All their application software. Okay, see all these application softwares running on top of OS. Okay, yes, all of these things running on top of OS. That means here OS giving platform to run all the programs. To run all the programs, OS giving platform. Okay, on top of OS, all the programs running here. So without this OS, these programs cannot run here. See, can we run any program without OS? No. Compulsory OS required. On top of OS, all are running here. Okay, so it's like a platform, acting like a platform. On top of it, all are running here. So OS acting like a platform. On top of it, all are running. So what is OS? What is operating system? Simply our answer. Answer, yes, it is a platform. OS, it is a platform. It's a platform. It's a platform. OS, it's a platform where where we can run all application softwares. Where we can run all application software. Okay, so it's a platform, acting like a platform to run all the application software, right? It's a platform. So what is OS means? Simple answer. What is OS? Simple answer. It's a platform. It's a platform where we can run all application software. Okay, fine. Not only platform here. Suppose, for example, yes, C program generating some output. So first of all, output of C program goes to OS. Okay, so output of C program goes to OS. From that, it goes to output device. Okay, so output of C program first of all transfer to OS. From that transfer to output device. Suppose reading from the keyboard. Yes, reading from the keyboard. So first keyboard data goes to OS. Yes, OS to C program. Similarly, Java. Suppose Java program delivering output here. Delivering output. So first Java output first of all goes to OS. OS to then output device. Maybe display screen. Okay. Similarly, reading. Reading from keyboard to OS to Java program like this. OS was like this. Okay. So between application software, yes, hardware, there is a OS. Okay. All the application softwares communicates with the hardware through the OS. So between application software and hardware, there is a OS like a mediator. Mediator. Exactly, we can say it's an interface. It's an interface. So OS, it's an interface between application software and hardware components. So next point. So OS, yes, it is an interface. It is an interface. It is an interface. Yes, OS, it's an interface between. It's an interface between, yes, application software, application software, application software and hardware components and hardware application software and hardware components Okay, application software and hardware components okay, 1 second. Yes, hardware components, it's an interface. So OS is an interface between application software and the hardware components. So everything is happening through the OS. Okay, see this application software maybe Java or C++, these things directly cannot communicate with hardware. There's no direct communication. Don't have direct communication. There's no direct communication here. Okay, so application software, yes, with the help of the OS, it will communicate with hardware components. That's it. See, to communicate between application software and hardware, OS has some library. So OS, yes, some libraries are like some input output library. So every OS has its own library. Yes, every OS has its own input output library to communicate between application software and hardware components. So what is library? Library, it's a collection of functions. It's a C language library. Yes, OS developed in C language. Almost all operating systems like Unix developed in C language, Linux in C language, Windows in C language, Almost all the operating systems were developed in C language. So it is C library here. Library means C language functions like input output functions here. Input output functions. Okay. So every OS has its own library. Every OS has its own library to communicate between application software and hardware. Yes, see, for our discussion, this is very useful topic, library topic here. Okay, Java is independent platform. To understand this, you must have this OS library knowledge here. Okay, so OS library. So here with the help of library, OS communicates between application software and hardware components. Okay, so next point here, see every OS has its own library, its own library. Yes, its own library to communicate. Yes, to communicate, to communicate between application software and hardware components. Okay, so with the help of library, it can communicate. So in every ways, library is there. Library is a collection of input output functions. Input output functions like scanf, printf, they are C language functions. Scanf, printf, something like this. Okay, right? Yes, next. One more thing, one more important point is in Java perspective, some important points. See, suppose C program communicating with the hardware. How it can communicate the hardware here? Suppose C++ program communicating with the hardware here. Java program communicating with the hardware here. There is no direct communication. No direct communication between application software and hardware. So what happens here? Suppose C program. If it is C program. So first of all, C program. C program links with the OS library, half linked, then communicates with hardware components. Even C++ also. That should be linked with OS library to communicate with hardware components. Even Java also. Java program also has to link with OS library to communicate with the hardware components. Means every program, maybe C program or C++, maybe Java program, maybe .NET program or Python or Hadoop, whatever it is here. The programs, every program has to link with the OS library to communicate with the hardware components. Yes, try to remember this point. This point is very, very important. Okay, so every program, see every program has to link with OS library, OS library to communicate with the hardware components, to communicate with hardware components, Okay, so every program has to link with OS library to communicate with hardware components. See what happens here. Before executing any program, first of all, it will link with OS library. Suppose C program, before running, first of all, C program links with the OS library. After that, starts executing. Even Java program also. Java program, before starting Java program, the Java program first of all links with OS library. After that, then starts executing. Before running any program, before starting executing any program, before starting here, first of all, yes, that program links with OS library. So once linked with OS library, then execution starts. Right? So once execution started here, using library, it will communicate with the hardware components. So every program has to link with OS library to communicate with hardware components. Yeah, that link may be static link or dynamic link. Suppose if it is C and C++ is static link. Suppose Java and Python is a dynamic link. Yes, we'll discuss. Wait, I'll explain very clearly what is static link, what is dynamic link. Practically, I'll show that. It's not theory explanation yet. Practically, how static link working, how dynamic linking working, we'll discuss practically. Okay, with the programs, with examples, I'll explain here. Okay, yes. So this point, try to remember this point. So every program links with OS library to communicate with hardware components. So every program has to link with OS library to communicate with hardware components. So this is about just OS area. Now you can understand it easily. Java independent platform, you can understand now here. Okay, so this is about OS. Okay, fine. Yes, next step. Yes, let us go document. So this is our document here. See the documents. Introduction to software. Yes, software is a collection of programs like this. Yes, software basically two categories: system software, application software. System software, it interacts with the hardware components. Example, device drivers, operating systems. Application software, for the purpose of application development. Examples, C, C++, Java, something like this. Okay, so what is OS? So the same, that points. Okay, yes, see, it's a platform where we can run application software interface. Okay, next, every operating system has its own libraries to communicate with application softwares and hardware components. Just 1 second. So one more point missing here. 1 second. Yeah, this point. Every program has to link with marriage. Yes. Every program, yes, has to link with OS library. So every program has to link. Okay. So every program has to link with OS library to communicate with hardware components. Fine. Okay. Hardware, on top of hardware OS, on top of it application software. Okay. Fine. Yes, here. Okay. System software, application software. Java comes under application software. Now let us move to application software. So application software. In application software, they say front end and back end. So what is front end? See, front end. What is front end? See, here this is here some form, right? Collecting your information, right? This is called a front end. It's a user interface. Front end, it's the interface, user interface. Taking data from users, and storing somewhere. Okay, so this is called as front end. Interact with the end users. We are the end users. We are providing some information, right? Some data. We are providing some information. So front end taking your all this data and storing it some location. This is called as front end. It's a user interface. Okay. Yes, it interacts with end users. Front end, it interacts with end users, collecting data from end users and storing somewhere. Yes, storing somewhere. That location is called as backend. Backend is a location where storing and maintaining all the data. Okay. So front end, backend here. In application software, there's a front end software, backend software. So backend to store and maintain data. Examples, databases and files. Databases and files comes in this category. Okay. So what is Java? Is it front end, back end here? Java comes on the front end here. It's a front end. Okay, front end to interact with end users. Yes, to interact with end users. So Java comes on the front end. So let us move to front end here. In front end, language and packages. Package is a predefined one, ready-made one, ready to use. Okay. Java comes on languages. In language, we should write the coding here. Now let us move to languages. Yes, our topic is languages. Okay. So next topic is languages. See, try to understand how I'm introducing Java, the way introducing into Java. See, start with software. Yes, actually start with computerware, hardware and software. Java comes as software. That's the reason started software. In software, system software, application software. Java comes under application software. So that's the reason move to application software. Okay. Yes, in this front end, back end. Java comes in the front end. So move to front end. Okay, moving to front end here. Okay. Yes, in this language and package. Java comes in language. So that's the reason move to language. Okay, now let us see languages here. Okay. From this onwards, we should discuss. Okay. So language. So what is language? What's a language? Language is a media of communication. Language is it's a media of communication between two living things. It's a media of communication between two living things. Okay, maybe two persons or two animals or two trees, something like this. Okay, yes, let us come to software. In software, we are understanding some language. Computer understands some other different language. So what is our language? What is computer understandable language here? See, our language looks like English language. For example, here, let us take some program. Suppose Java program. Suppose Java program. Java. See, this is Java program. It's looking like English language. It's a user understandable language. So like English language, it's a user understandable language. Okay. Suppose for example, let us take some HTML code. HTML. So this is the HTML code here. This HTML code. HTML. Yes, like English language. This is like English language. It's a user understandable language. It's not a system understandable. It's a user understandable. User understandable. One more example. Suppose let us take Python. Python code. Yes, Python. Suppose some sample program, some test program. Open, notepad. See, Python script. Just like English language. Yes, this language user understandable called as high level language. Okay, high level language. Okay, so there are, yes, here language like high level languages, user understandable. So in language here, yes, high level languages, high level languages. So high level language, user understandable, high level language. Okay, high level language, high level language. Yeah, these are user understandable language, user understandable. Okay, like C, C++, Java, all are high level language. These are user understandable, understandable languages. Understandable language. They are user understandable languages. So these are like English language, very easy to understand here. Like English language, so easy to understand. High level language. These are user understandable language, very easy to understand, like English language. Okay, right? Yes. Second one. System understandable languages, user understandable and system understandable. System understandable language, yes, is in the form of zeros ones format called as binary code. It's a machine language. It's a machine language here. So next is low level language. Yes, high level languages. See, first one, high level languages, user understandable. Next, low level languages, they are system understandable languages. Okay, these are yes, system understandable, system understandable languages, system understandable languages. Okay, so low level language, they are system understandable language. Okay, yes, it is in the form of, binary code. It is in the form of binary code. It is in the form of binary code. Okay, low level language, it is in the form of binary code. It is in the form of binary code. Binary code like zeros ones format. Zeros ones format. It's a binary code. Okay. Yes, it is a machine language. Yes, it is called as, machine language. It's a machine language. It's a machine language. It's a machine language. Okay. So low level languages, low level language, it's a system understandable language. It's a system understandable language. Yes, it is in the form of binary codes. This is binary format. Binary format. It's a binary format. Binary codes. Okay. Yes, it's a machine language. Called as machine language. Okay. Right? Yes. See here, high level language and low level languages. Okay. In this, here in low level language, high level language, some generations are there. See, first GL and second GL comes under low level languages. When come to high level here, in high level, yeah, they say third GL and fourth GL, third and fourth comes under high level language. Okay, let us see generation of language. What is generation of language? Generation of languages. Generation of languages. Okay, there are four generations. First GL and second GL. Okay, first and second generations. Next third and fourth. First, second, third and fourth. Yes, first generation, it's a machine language. First generation, see, first generation machine language in the form of binary codes. First GL, it's a machine language, system understandable language. So it is a binary code. This is binary code. It's a binary code. So this is binary code, like zeros ones format, binary codes, zeros ones format. Second GL, what is second GL? It's assembly language. Yes, assembly language. It's assembly language. Okay, assembly language. Okay, it's assembler understandable language here. Assembly language. Okay, assembly language. Okay, see, these two are system understandable languages. So need not to learn these things. System internally using these two languages. So these are not required for us. Okay, so system yes using internally. Okay, these two are low level languages. Okay, right? Next, high level languages. Third and fourth generation. Java comes in a high level language. C language, C++, Java, Python, all are high-level languages. Okay, so high-level language. First and second generation is low-level language. Third generation, fourth generation, high-level language. Yes, yes. In generations, Java comes in fourth generation. Java it's a high-level language. Okay, Java high-level language in that comes under fourth generation. Java is a fourth generated language. Okay, third shell. Third shell in third shell there are some procedure-oriented languages. Procedure-oriented languages. Procedure-oriented languages. Okay, like COBOL. Yes, COBOL very old language. Yes, even old language still is in use. COBOL using for the mainframe applications. COBOL using for the mainframe applications. Still mainframe applications are there in the market. Yes, in our office also mainframe applications are there. Yes, COBOL team is there. COBOL team is support guys are there. COBOL team is there. Okay, COBOL. Yes, it's a procedure-oriented language. Procedure. What is procedure? We'll discuss. What is procedure? I'll explain. Okay, COBOL, Pascal. Yeah, Pascal. This was outdated. No one using. COBOL using here, but Pascal not using here. Pascal, Fortran, very old language. Fortran. Next, Lisp, AutoCAD Lisp, like AutoCAD, like drawing, okay, like civil drawings, mechanical drawings. That case using AutoCAD Lisp here, Lisp. Okay, next, one more Python. Python comes under procedure-oriented language. Python procedures concept is available, so it's a procedure-oriented. Okay, yes. Next, fourth generation. In fourth generation, first one, functional-oriented languages. Functional-oriented languages. So fourth generation, first functional-oriented languages. Okay. Next, second one. Second one, yes, Object-oriented programming language means OOPS language. Object-oriented programming language. Java comes under this one here. Okay, Java is a object-oriented. Java comes under object-oriented programming language. Okay. Next, third one here. Yes, object-based language. Object-based languages here. Object-based languages. Third one, object-based language. Okay. Next, fourth one is purely object-oriented programming language. Purely object-oriented programming language. So these all are fourth generation. Nowadays, we are using fourth generation. Okay, all are what are language we are using here? All are fourth generation. Okay, functional-oriented language. It's a C language and Python. Yes, in Python we can write procedures and functions both. In Python, in C language only functions, no procedures concept in C language. C language don't have procedures, all are functions. In Python, we can write procedure and functions both here. So what is procedure, what is function? Let us see. Suppose some X, open bracket, close brackets. Yes, it's like a procedure, like a function this is. So procedures and functions looks like same. Okay, procedure, function, same. Both are same, but some little bit difference here. What is the difference? We'll discuss. Some X is a function or procedure. See here, procedures and functions. Some statements, set of statements. Procedure or function. Procedure and function both are set of statements. Set of statement to perform some task. The difference is here some written value. Suppose written is written of 10. Some value maybe 10 or 20 something like this. This is called as function. This is procedure. First one is a procedure. Second one function. Okay. Yes. Function, procedure. Both are set of statement to perform some task here. Procedure, function, both are set of statement to perform some task. The difference is here. Procedure does not return a value. Whereas function returns a value. Written value is different here. Yes, if it is returning value, it's a function. No written value, it's a procedure. Procedure, function difference is that. Okay. Yes, in Python, we can write procedures as well as functions. Both you can write in Python. We can write both here. In Python, we can write both. In Python, we can write both here. Okay, yes. So this is procedure and function difference. C language only functional oriented. It does not support others. Next, object oriented programming language. So what is object oriented programming language here? Okay, here, yes, it's a OOP concept here. OOP, yes, OOP, yes, OOP concept. Yes, what is OOP exactly? OOP, object oriented programming. It's a concept. It's not a language. OOP is a concept. It's not a language. Okay, so why OOP concept was developed? Because it is here to achieve data security. Its main purpose of OOP is to achieve data security. So before OOP, we have the C language. In C language, everything is global. Data is global, functions global, everything is global. Since everything is global, anyone can modify the data from anywhere. From anyone, anywhere. Yes, from anywhere, anyone can modify the data. Anyone can access data, anyone can modify data. So there's no security for data in C language. C language disadvantage. C language disadvantage, no security for data. No security for data in C language. To achieve data security here, OOPS concept was developed. OOPS concept was developed. So initially, OOPS concept was developed with two features like encapsulation, yes, encapsulation, okay, data abstraction. Encapsulation, data abstraction. So what is encapsulation, data abstraction? We'll discuss later. Next coming topics I'll explain. It's an actual Java. We'll discuss what is encapsulation, what is data abstraction. We'll discuss next. Okay. In Java OOPS I will explain. Practically we'll discuss. Here first initially OOPS was developed with these two features: encapsulation, data abstraction. Okay. To achieve data security, OOPS was developed with these features here. OOPS concept, the OOP concept was developed with these two features. Okay, to achieve data security. Yes, later added so many features. Okay, so many features like yes, method overloading, next constructors, destructors, operator overloading, next inheritance, polymerization. 1 second, encapsulation, data abstraction. Yes, next method overloading. Yes, method overloading. Yes, method overloading. Encapsulation, data abstraction, method overloading. Yes, next constructors. Yes, constructors. Yes, next inheritance. 51. Inheritance. Yes, inheritance. Yes, inheritance. 6th one, polymorphism. 7th one, destructors. Yes, destructors. Yes, 8th one, operator overloading. Yes, operator overloading. Yes, operator overloading. Yes, next. Yes, next, method overriding. Method overriding. Yes, next, templates. Mean generic concept. This is some templates concept. Templates. It's a generic concept. Some generic concepts. Okay. So these are the OOP features. And there are 10 features. But no language supports all that features. C++ supports maximum features. C++ supports maximum features in this. Okay. In C++, except these templates, yes, everything is there. All of this. Yes, C++ templates concept is there, but very poor, somewhat poor in C++. Okay. Yes. OOP was there with these features, 10 features. Out of all these 10 features, out of these 10 here, first 6 are the powerful features of OOP's concept. Okay. First six are powerful features. So any language which is supporting first 6, that language is called as object-oriented programming language. Yes, 6 enough. Need not to support all that features. All are not necessary here. At least 6. At least these main powerful features. That language called as object-oriented programming language. Now, which is first OOP's language? Yes, anyone idea? Which is first OOPS language? Which is first OOPS language? Any idea? Yes, which is first OOPS language? C++. First OOPS language C++. What is next OOPS language? First is C++. Next is Python. Python. Yes, after Python, what is next OOPS language? What is next OOPS
Java.
language? Java, right? Java. After Java, what is next? After Java, what is next? No idea. .NET. .NET C Sharp, right? C Sharp. Yes, after .NET C Sharp, what is next OOPS language? What is next OOPS language? Scala. Scala. Latest one is Scala. Scala using for the data processing. It's Spark framework, big data processing. Scala. Recently language. Okay. Yes. So these are the OOPS languages. They're OOPS language. Next, object-based language. See, object-based language, object-oriented programming language, both are similar. Both are similar. Both are similar. The difference is here. Yes, both are similar. The difference is inheritance, except inheritance. Both are similar. Okay. Yes, in object-based language, here also you can define classes and objects. In OOPS language, yes, using classes and objects. Same thing in the object-based language, also you can define classes and you can create objects, you can use objects, but does not support inheritance. Okay, object-based language does not support inheritance. Except inheritance, everything is same here. For this example, JavaScript. JavaScript. See, JavaScript is not a Java. JavaScript is different. Java is different. Okay. Java program executing by the JVM. JavaScript executing by the browser. JavaScript is a browser understandable language. JavaScript executing by the browser. Okay. Java program executing by JVM. So JavaScript is different. JVM is different. JavaScript is different. JVM is different here. Okay. So in JavaScript, we can define the classes. We can create objects, but don't have inheritance. Except inheritance, both are similar. Except inheritance, both are similar. Right. Next, purely object-oriented programming language. This is Scala. Scala and Python. Scala and Python. See, in Scala and Python, everything is objects. Purely object-oriented means everything is objects. Everything is like object here. See, whenever you talking object here, immediate data security comes to picture. If object format means data stored in the form of object, there is data security. If data in the form of objects, then data security. Yes, why this OOPS concept? Data security main purpose. Okay, if object is there, means there is a security for data. There is security for data. Yes, purely object-oriented programming means everything is object. In this, everything is object here. Yes, everything is object. For example, int a equal 10. So where this 10 storing? In variable a. This 10 storing into variable a. Suppose if it is variable, data is not secure. If data in the variable, that is not secure. Yes, in case of variable, if it is object, suppose integer, yes, integer objects, integer, yes, I1 is equal to, yes, new integer, yes, integer I1 equal new integer by passing 10. Now, this is 10 storing like a object format, like object, inside the objects. Okay, if data inside the objects, data security. Suppose if it is variables, no data security here. Okay, so you can even integer type of data also storing like objects. Suppose something like a float f equal 20.5. Yes, this also storing like a, yes, integer data, float data. Yes, all this data storing like objects. Yes, even basic data also storing like object, called as purely object oriented. Everything is like objects. Okay, even this kind of data also storing like objects. This kind of data also storing like objects. One second. Yes. So everything is like an object format. Everything like even integer type of data, float type of data, character type of data, all the type of data storing like object is called as purely object oriented. Purely object oriented example is Scala and Python. Okay. So these are different languages. Now, if you guys tell me something here. Now, which is commonly, yes, language here, which is common language in all these here, which is common language?
Python.
In all these languages, which is the common one? Yes, anything absurd? Which is absurd here? In all of this, which is common language? What's a common language you observed here? What's a common language you observed? Nothing absurd. Try to observe it. Procedure oriented, COBOL, Pascal, Fortran, Basic, Python. Functional oriented, C and Python. Object oriented, C++, Python, Java, Scala. Yes, purely object oriented, Scala and Python. Tell me, what's a commonly observed?
Python.
Python, right? Python. Python is everything. In Python, we can write procedures, functions, and objects. Okay, purely object oriented also. Python is procedure oriented, functional oriented, object oriented, purely object oriented. Python is everything. Okay, so these are about different languages. Okay, fine. Next, see here. 1 second. Let us go document. See language, low level language, high level languages. Okay, low level languages. Yes, machine language, assembly language comes in low level language. High level user understandable, all their user understandable. So third and fourth generation. See, generation of language. First generation, second generation, third and fourth. So low level, first and second generation low level. Third and fourth, it's a high level language. High level. Okay, fine. Yes, here high level language. See, this is high level language. Suppose HTML code is a high level language. System cannot understand this. System can't understand this. User understandable here. Java program, it's a high level language. It's a user understandable language. Okay. Yes, maybe suppose some Python codes. Python codes. It's user understandable. But system cannot understand this. These high level languages have to convert into binary codes. First of all these user understandable language have to convert into system understandable language, means binary format. Yes, who will convert from high level language to binary codes? Who will convert it? Yes, someone have to convert here. Okay, which one will convert? Which one will convert from high level language to binary code here? For this, either interpreter or compiler. Suppose if it is Python script, interpreter will convert. Suppose C program, compiler will convert. C++ compiler will convert. Like this, either interpreter or compiler. So either interpreter or compiler converts from high level language to binary code. After converting from high level language to binary code, that code submitted to processor. So processor taking that code, executing and giving output. Okay. See, whatever the code you're writing here, that code is called a source code. The code is called source code. Okay, source code. Maybe Java program. 1 second. See here, this is a Python program. It's a Python script. So this is source code. Your code is a source code. This is source code. Source code. Okay. Java program. This is source code. So whatever the program we are writing, yes, our code called as source code. Now this source code converts into binary code. This source code converts into binary code. The source code converts into binary code. So there is one for system understandable language. Source code converts into binary code. Okay. Yes. So which one will convert source code to binary code? Binary code here. Either interpreter or compiler. Either interpreter or compiler. Either interpreter or compiler converts from the source code to binary code. After converting here, the binary code submitted to processor. So processor taking that code, okay, executes and generating output. And here processor executes, Yes, executes that binary code here, finally generating output here. That's it. There are steps in this. Okay, generating finally output, right? So first is source code. So what are the code we are writing? That code is kind of source codes. Maybe Java source code or C program source code or HTML source code. The source code converts into binary codes. Binary codes. Okay. So after converting to binary code zeros ones format, that code submitted to processor. So processor taking that code, executes, finally generating outputs. That's it. Okay. Now source code to binary code. This is by the either interpreter or compiler. Interpreter, yes, interpreter or compiler here. Either interpreter or compiler. Okay, right? So interpreter versus compiler. Yes. So what is interpreter? What is compiler? Exactly what is interpreter? What is compiler? Interpreter versus compiler. So what is interpreter? What is compiler? Okay. Yes, let us see. Yes. Can I continue for next 15 to 20 minutes? Is it okay? Yes, guys. Hello.
Okay, sir. Okay, sir.
Next 15 minutes. Within 15 minutes, we'll finish this. Interpreter versus compiler. So what is interpreter? What is compiler? Let us see. Yes, interpreter versus compiler. Yes, interpreter. First, let us take interpreter. Yes, interpreter. Yes, anyone have the idea? What's the difference between interpreter and compiler? Simple answer. At least one point. Interpreter and compiler. What is interpreter? What is compiler? Just I'm asking your idea. I'm here to explain everything. Don't worry. I'm here to explain everything. I'll explain. What is interpreter? What is compiler? What's the difference between these two? Okay, no problem issue. Yes, interpreter. How interpreter is working? Yeah, interpreter is step-by-step process. Okay. Compile is, what's a compiler? Whole program at a time. Yes, yes. Generally expect answer. Anyone says that interpret is line by line. Yes, compile it at a time. Whole program at a time. Okay, fine. Well and good. Okay. Yes. Now that is exactly what is interpreter. What is compiler? First, let us say about interpreter. Suppose interpreter source codes. Some source codes. For example, here test.py. Suppose Python script. Let us take Python script. Python script. Suppose this is Python script. Python script. This command prompts. Command prompts. D type. Yes, the command of Python. CLS. CD. Command of Python. Yes, DR. CLS. DR. Suppose this is test.py. Test.py. Yes, notepad. Notepad. Yes, test.py. So this is Python script. A equal to B equal to C equal to A plus B. Addition, subtraction, multiplication. Simple program. Addition, subtraction. Okay, C equal to A plus B, C equal to A minus B, C equal to A into B here. So this is the Python script. Okay. Now this script direct I'm submitting. Yes, no checking errors, nothing. Without checking errors, directly I'm submitting. Python. Yes, I'm running. Yes, working fine. Yes, errors, nothing checked. No comparison process, nothing. No error checking, nothing here. Directly submitted. So directly executed. Directly executed. Suppose, for example, A equal to okay, equal to C equal to A plus B. Suppose here comma missing. What happens here? Let us see what happens. Yes. What happens here? See, yes, error messages. Line error and stop it. So once error comes will be stopped. It's not checking for next coming errors, next coming statements. So here stop it, right? Yes, here how that interpreter is working. Interpreter is working. Let us say about interpreter. How that interpreter is working. Suppose this is your Python script. For example, Python script. Python script. One second. Python script. Yes, first statement. Python script. First statement. Suppose next statement. Yes, next statement. Python script. Okay, so next statement. Yes, next statement. Yes, next statement. Next statements. There are some statements like this. Next statements. Python script one by one statements here. So next statement. Yes, next statement. Okay, next statement. There are some statements in Python script here. Fine. Okay, so this is for Python script interpreter based source codes. Okay, so the Python script statements here. Python script statements. One second. So this is, yes, there are statements. First statements, next statement, next statement, next statement. There are statements here. Statements. Line here, line by line. Statements here. Okay. So there are, yes, statements like this. Now interpreter. How interpreter is working here? So first of all, interpreter checking first statements. Checking first. Suppose first statement is correct. First statement is correct. Immediately the statement converts into binary code like zeros ones formats. Zeros ones formats. Then yes, this submitted to processor. So processor taking that code, generating output. Right? Okay. Yes. See, suppose the statement is correct, immediately converts into binary code and generating output. See, next statement, next coming statement may be right or wrong. Interpreter never think about next coming statements. The interpreter never think about next coming statements. Interpreter here never think about next coming statements. So next coming statement may right or wrong, never thinking. Suppose if the statement is correct, immediately converts into binary code, then generating output. Yes, after checking for next statements. Checking for next statement. Suppose next statement. Checking for next statements. Suppose next statement also correct, same process. Converts into binary code. Just converts to binary code. Binary code are given to process generating outputs. Okay, right? Next, checking for next statements. Checking for next statement here. Checking for next statement. Suppose something wrong here, stops. Just now we did. Yes. See that? At 7th line, error stopped. Okay. So once error comes, it stops here. Checking first statement, next statement here. Here it's error here. Checking first statement and immediately generating output here. Statement is correct, immediately getting output. See, next coming statement may be right or wrong. Never think about next coming statements. Yes, if the statement is correct, immediately generating output here. So checking and convert into binary code, generating output. Checking, convert into binary code and getting output here. If any error, simply stops. If any error comes, simply stops. So this is working of interpreter, right? Okay. Yes. Same thing if it is compiler, how it works. Let us go for compiler. Okay, compiler. Yes, let us take some compiler based program, C language, Linux based C language, Linux based. Yes, if it is compiler, how compiler is working? Yes, compiler. Yes, if it is compiler, source code maybe C program, test.c program. Okay, how it's working? If it is compiler, how it's working? Okay, let us see one by one. Yes, if it is compiler, how it's working? One second. If it is compiler, how it's working? Log into Linux base. Yes, compiler, how it's working? See, compiler checks the first statement. After checking first statement, suppose correct, even correct, it won't convert into binary code. It won't. Next, checking for next statement. So this also correct, even correct, it won't convert into binary code. Next, after checking for next statement, suppose something wrong here, error at source line. Okay, checking for next statement. Even error is there, it goes next line also. Suppose interpreter, any error comes, stops. Interpreter, any error comes, stops. But compile is not like that here. Even error is there, it goes next statement, checking for next statements. Next statements. Okay, suppose something wrong here, error at some line here. So next, checking for next statements. Checking for next statements. Like this top to bottom. Yes, compile checks the whole program from top to bottom here. Checking for all statements from top to bottom shows all the errors. Interpreter is line by line checking and line by line output here. But compiler is not like that here. Okay, so compiler, yes, checks whole program from top to bottom and shows all the errors. Interpreter is only one error. Any error comes, interpreter stops. But compiler is not like that here. Compiler top to bottom checking all the lines and shows all the errors. All the errors. Okay, one second. Let me show that practically. Compiler, how compiler is. Yes. Let us take some C program. CD
అది బారు
means L not. Suppose CDX permission data CDY less. Okay, fine. Yes, here. So one C program here. Let us write C program. Yes, gedit test.c C program. Yes, hash includes stdio.h. Okay, next white main function starting yes this int a is equal to 10, like a Python program, same program in C language. Int b is equal to 20. Next int c declaration, int c. Next here c equal to a plus b, a plus b. Okay, yes. Next printf yes addition, yes addition is equal to %d comma c, displaying a c value, slash and will take next line. So displaying c value semicolon. Okay, yes, c equal to a plus b, c equal to a minus b, c equal to a into b, c equal to a minus b. Yes, it's a subtraction. Next subtraction. Okay, next yes a into b multiplication. Yes, multiplication is equal to c, displaying c value. Okay, c equal to a plus b, c equal to a minus b, a into b like this. So this is C program. Okay, yes. Next end of main, closing main, save and close ls. Now see that test.c program, test.c program. Now you have to compile. It's a compiler based. You should compile. Directly can't submit here. You have to compile it. Okay, directly you can't submit here. So cc-c test.c. You have to compile it. Test.c compiling. Yes, compiled. See this. Test.o file created means binary code file generated. It's a binary code. Now test.o kind is binary code. Correct. Now cc-o. Suppose result file is project.exe. Project will here test.o. Right? Yes. Let's see that project.exe file generated finally. It's exe file. Exe file. Now what happens here? Now project.exe file generated. This exe file contains what? See here, while creating exe file, that how that exe file is creating here. Yes, cc means C language compiler. C language compiler hyphen o means object files. Yes, the C language compiler hyphen o means objects means you take all the object files. Now what are the object files here? See, for our program test.c, test.o, it's object file. It can be binary code. Binary code of our C program. Test.o contains binary code for our C program. Test.o contains binary code for our C program. This is this binary code. So test.o contains binary code for our C program. Okay, fine. Next one more here. stdio data header file. Right? Here this is stdio data header file. This header file is also having its own binary code. Okay, stdio data header file. For this also object code is there, binary codes. Yes, apart from this, next OS library. OS library also in the form of binary codes. OS library also in the form of binary codes. Now what happens here? At the time of generating exe file, That C compile linking all the object files. That means binary code of your program test.o, binary code of C language library std data center file, binary code of OS library. By linking all this, generating exe file. So finally, exe file contains what here? Your C program binary code. Next, C library binary code, std data center file binary code. Next, OS library binary code. That is complete exe file. After generating exe file, then run it. Yes, addition, subtraction, multiplication. So what was happened here? After compilation, if no errors, generating one exe file. After generating exe file, that exe file executed. Okay, so exe generated here. Yes, in case of Python script, what was happened here? Directly we are submitting, right? See, in Python script, what's happened here? Suppose no error. Yes, save. Yes, error. Okay, now here Python script. Python, yes, direct executed. Yes, generate output, right? Directly we got the output here. Okay, yeah, directly executed, directly got the output. Okay, no exe created. But in C language, what happens here? Exe file created. That exe file created, that exe generating outputs. Okay, so in case of yes, C language here, exe file executed and given output. Say compiler based. Yes, if it is Python, interpreter based, direct executed. Okay, so this is main difference here. Yes, here compiler generating one exe file, interpret no exe file. See, compiler checking program from top to bottom, checking from top to bottom. So shows all errors, all errors. See that. Even let us see errors also, with errors also. ls, suppose remove star.to file. Yes, remove. Yes, p star. Okay, remote ls. Okay, now read test.c. Test.c. Yes, let us make it some mistakes here. Some mistakes. Comma missing, comma here. Yes, here semicolon. So maybe yes, comma missing. Save. Save and close. Now let us compile this. Let us compile cc -c. See this. All errors top to bottom, right? See error rate. See eighth line error. Okay, next eighth line error, 10th line error, 9th line, top to bottom. So this is showing all the errors. Yes, interpreter is only one error, only first error. Once error comes, it stops. But compiler is not like that here. Compiler shows all the errors from top to bottom. Compiler shows all errors from top to bottom. It shows all the errors. All the errors. Okay. So compiler shows all the errors. Okay. After correct all these errors, semicolon. Okay. Next comma. Yes, these errors. Yes, after correction. Yes, now let us recompile here. Recompile. See. Recompile. Let us recompile. Again, still error. One more error. Yes. Let us modify that error. So here, correct that error, fix that error. Yes, comma. Okay, done. Save and close. Now let us recompile cc-c. Yes, still one more error. Okay, one more printf before that, semicolon missing. Printf before, semicolon missing. Okay, now compile it. Yes, compile it. See test.o file generated. Now next cc from project exe name is project result exe test.o, right? Test.o, that project exe file generated. Got the exe file. Now run it /projects. Yes, running project file, right? Yes, executed. Direct executed, right? So exe file executed. Okay. So what was happened here? If no errors, here, yes, no errors. Everything is correct. No errors. Everything is fine. So compiler checks the whole code from top to bottom. Okay. Suppose here no error. Suppose here also no error. Yes. Here also. Yes, no error. Everything is fine. If everything is fine here, then compiler, yes, generates one exe file. So another file, it opens another file called as exe file. Okay, that exe file. Okay. This whole code converts into binary code. First line converts into binary code. Next line converts into binary code. So next line converts into binary code like this. So next line, this whole code converts into binary code. Complete codes converts into binary codes. Okay, convert into binary code. and generating exe file. Just generating exe file, right? Exe, that project exe file generated here. Project exe. That project exe file generated. Okay. Is .exe extension optional in Linux base. Project exe file generated. Now this exe file submitted to processor. Yes, then generating output finally, right? Generating output finally. Okay, right? Yes. So this is working of compiler. Yes, if compiler checking whole code from top to bottom, if no errors, generates exe file. That exe file submitted to processor. So processor giving output simply. That's it. So this is difference between interpreter and compiler. Okay. Let us see points wise. Interpreter versus compiler, the differences. Points wise. Yes. Interpreter. Yes, interpreter. Interpreter. Next compiler. Interpreter and compiler. Okay. What's the difference? Interpreter and compiler differences here. Differences. Interpreter. Yes. Yes, interpreter checks the code line by line. Line by line checking here. Not whole program. Compile is whole program. Yes, checks whole program at a time here. Top to bottom checking. Compiler whole program checking here. Okay. So interpreter checks the code line by line. Yes, compiler whole program. Next output. Okay. So interpreter line by line output here. Line by line. Line by line output here. Line by line output here. Output is line by line. Line by line. Yes, output is line by line. If it is compiler, it's exe file, right? So at a time executing exe file and giving output here. So top to bottom executing. So at a time output. So getting at a time output here. At a time outputs. At a time output here. Okay. So your interpreter checking code line by line. Compiler whole program. Yes, interpreter output is line by line. Compiler at a time output here. At a time outputs. At a time outputs. That okay? Yes, next. See, any error comes, interpreter starts. It shows only one error. Only one error. It shows only one error. Only one error. Okay. Yes, compiler all errors. It shows all errors. Compiler all errors. Right, okay. Next, main difference exe file. Yes, it does not. It does not generate. It does not generate exe file. Exe file. Yes, it generates exe file. Compiler generates exe file. This is main difference. Compiler generates exe file. Okay. Interpreter does not generate exe file. Does not generate exe file. Compiler generates exe file. Compiler generates exe file. Okay. Fine. Next here. Yes, if it is interpreter based, directly source code executes, right? Directly source code executes. Directly source code executes here. Source code executes. Okay. Compiler exe file executes. Exe file executes. Exe file. See, interpreter, Python script, directly source code executing here. Directly that source code executing. Okay, directly. Yes, Python test.py file executing. But compiler based, what was happened here? Exe file, the project exe file executing. Okay, that's a difference here. Okay, yes, next difference. Interpreter based language examples. Yes, all these are examples. One second. Yes, these all are scripting language. All are scripting language. Okay, these all are scripting language. They are all scripting language. Okay. Yes, compiler based programming language. The programming language. Programming languages. Programming. If they are programming languages. Programming languages. Programming language here. So interpreter based. All scripting language. These are programming languages. Programming languages. Okay. Programming languages. Yes, programming language. Okay. Yes, all scripting language, interpreter based language are called scripting language. Compiler based language called programming language. Programming language. Okay. Yes, interpreter based language examples. HTML is interpreter based language. Python. Yes, it's interpreter based language. HTML, Python, next PHP, next Perl scripting, next Linux shell scripting, the interpreter based language. Compiler based examples: C, C++, next .NET, C hash. Okay, yes. What is Java? Is it interpreter based or compiler? We'll see next. Java depending on both interpreter as well as compiler. The topic tomorrow we'll discuss. Okay. So interpreter and compiler. Okay. Yes. Next. See here. Yes, interpreter based language. That source code can be modified anytime here. Yes, source codes. Open this. You can suppose I don't want this line here. This statement I don't want. Okay. Yes, modifying and submitting immediately here. Direct you can submit. Modify and run it. That's it. Anytime you can modify. It's open source. Open source that can be modified anytime here. Suppose if it is yes, exe file, you cannot modify exe file. It's not an open source. Suppose gedit, zedit, that project exe file. Project exe file. Yes, gedit. Yes. Try to open that project exe file. It's opening here. Okay. Project exe file. Once it's opening, still text editor. Yes, see binary code, serious funds format. The binary codes. Okay. Binary codes. So how can you modify this? We cannot modify here. We cannot modify this. Is okay. So interpreter based, it's open source. It's open source. Open source. Yes. It can be modified anytime here. Open source means which is able to modify anytime here. Yes, it can be modified anytime. It can be modified anytime here. Anytime. It can be modified anytime. It cannot be modified. Not a open source. Cannot be modified. Cannot be. It cannot be modified. Cannot be modified. Cannot be yes modified. Cannot be modified. Cannot be modified. It's not an open source. Cannot be modified. Okay, right? Next, one more example here. Any language which is interpreter based, no exe file concepts. Okay. See interpreter. See interpreter. Interpreter based language. Interpreter based language. Interpreter. Yes, interpreter based language. Yes, interpreter based language don't have exe file concepts. Interpreter based language. Yes, don't have exe file concept. Don't have exe file. Don't have exe file. So here everything is exe file. Compiler based, everything is exe file. Everything is exe file. That's it. Everything is exe file. Yes, compiler based, everything is exe file. Always running exe files. Always running exe files. Okay, right? Yes, so this is difference between interpreter and compiler.